Hi, guys. Welcome to Mission Control Houston. I'm Kelly Humphreys, and this is veteran astronaut Mario Runco. We are ready for your questions.
All right. Do you want the students to be? Hi, this is Mrs. Sukumar from Bedford High School. Do you want me to ask the questions one at a time, or do you want the students to be asking the questions?
We'd love to hear directly from the students,
Sure,
but
why
they do
not?
need to speak up so we can hear their voices. And I want to make sure they know that Mario knows New Jersey. He went to Rutgers University and is originally from New York, so he knows your area.
Very nice. So let's start with Brant Wilson. He's a grade 11 student. He's a junior at our school. So Brant's question, here he goes. Brant,
How long have you in total just been in space?
How long have I been in space? I
Yeah.
had done three missions. The first one was in 1991 on STS-44. That was with the space shuttle. And then I did two more space shuttle missions in 93 and in 96. And the total time among all missions is was about 21 days total, which nowadays, compared to what the guys spend on the space station, is a very small number.
Okay, that's a great question, and just a reminder: please get to the microphone and speak up so we can hear you. It's a little hard.
sure. So the next question is from Brian McLachlan. He's a grade 9 student. He's a freshman. Brian, where are you? Brian's not here, but I'm going to ask the question that Brian had asked on his behalf. His question is, how is space always expanding, and where does it expand into?
How and why is space expanding and what is it expanding into? That is a great question that I don't think we know the answer to at this point. Space is as far as we have sensed with our Hubble Space Telescope and other orbiting observatories like the Gamma Ray Observatory. We know that there are objects that we can see and sense out 13 billion light years from Earth. So, and that's really the extent of the known universe. The objects in within that space, that the known universe, are expanding away from each other into distances farther than the 13 billion light years. Now, remember, a light year is about 6 trillion miles. So I said 13 billion times 6 trillion. So that's the distance to the farthest known extent of the universe, at least today. And that's a darn good question. And maybe Brian will be able to become the scientist that figures that out.
The other part of that is what exactly is in all of that space. And one of the experiments on the International Space Station, the alpha magnetic spectrometer, is doing sifting through the various cosmic rays and particles that come to Earth to try to identify a little bit more about things like matter, antimatter, and this theoretical dark matter that we believe exists because we can indirectly sense it, but we don't have any direct measurements of that. And so it's a really interesting experiment, and having the space station orbiting the Earth provides us the power to operate that outside the Earth's atmosphere and look more at what is in between the matter that we can see and sense. And we're ready for your next question.
Are you hearing me? Okay.
And I'm sorry, we're not able to hear that at all.
Something must have happened to the microphone.
I'm sorry, you may want to check your microphone and verify that it's in a good location and plugged in.
And while you're doing up, and while you're doing that, let me comment about what Kelly had just said, and that is with the dark matter. Uh, Scientists believe that there is a construct, a thing called dark matter, and that's because, for example, the Milky Way galaxy, our own galaxy, has matter in it, and it is spinning around in a disk-like fashion. But the rate of spin is such that the centripetal acceleration outward that would throw the objects within the galaxy, like the ball at the end of a string, when you let go of the string, they would fly outward and not stay as part of the galaxy. But there's enough gravity within that galaxy to hold everything together. But the matter and the mass that we know of in the objects that we can see is not enough to do that. So they've invented dark matter to try and solve the equation so it makes sense. So there's something there. We just can't sense it, and we don't know what it is. Now there are things out there called rogue planets that are like the Earth or Jupiter that do not revolve around a star, so they would be dark planets that we can't see. So maybe that's one possibility that's not so exotic that would account for that extra mass.
Okay, I'm hearing that we may have gotten the audio connection fixed. You want to try another question, guys?
Yes, we do.
Now that's
Oh,
better.
we can hear you now.
Yes. How do you feel in space? Do you feel more inspired and at ease, or do you become cynical?
Good question. I actually, it's the former. I feel very inspired and uplifted, and the reason for that is when you're in orbit around the Earth, you can see most of the Earth, and indeed some of the earlier astronauts who traveled farther away from the Earth, like those that went to the moon, could see the entire Earth at one time, and it is so spectacularly beautiful and majestic. And likewise, when you look out into the universe, you see the stars and the celestial sky in a much more vivid fashion, and your being among them, that in that setting just is very exhilarating and inspirational, and actually we had talked earlier, Kelly and I, about some of the work we were doing here at NASA that is related to that in terms of taking images of the Earth.
All right, next question.
Next question is from Michael Holmes. He's a freshman, and his question is, what do you use to work out in space?
Oh, good question. And you really need to work out in space. I'll answer the question, but let me just say firstly that on Earth, gravity is working on us all the time. And for example, like my heart is pumping blood right now up against gravity to my head to keep me conscious so I don't keel over in the chair. And when gravity is removed, the heart doesn't have to work so hard. Yet when I come return to Earth, it has to go back into that environment. So we need to stay conditioned because muscles that you don't use, as everyone knows, tend to grow weaker. So we need to maintain at least the level of strength that we had when we left the Earth. And we use devices such as ergometers and treadmills and cycling machines and bungees in a fashion that are all designed using springs and the like to mimic gravity. For example, if I'm running on a treadmill, there are bungee cords holding me to the treadmill such that I can actually run on the treadmill, and it works. And then we use bungees and stuff and spring-like things to mimic weightlifting and the like. So we try to do, and there are many devices that have been developed to help and facilitate that exercise protocol.
And just to add on to that, there are density loss is another important thing when you do the long duration stays in
True.
space. And so doing this kind of exercise puts force onto your bones in the same way that you would put force on your heels when you walk. And that helps keep the bones strong, which is a really important thing. And research into that is also helping us solve problems that people have on Earth, like osteoporosis. Some of your grandparents may have experienced that and have it's too easy to break a hip or whatnot because of that. And some of the research in space is helping us apply what we're learning there to diseases we have here on Earth. And so that's another part of exercise on orbit because these folks all come stay up there for about 6 months and then they've got to readapt to being on gravity when they get home.
And in the case of osteoporosis, it happens if we don't exercise, we tend to develop those symptoms in the very short period of time, in a matter of weeks and months. So we can study that, whereas normally on a person on Earth, it would take a lifetime before they develop any symptoms. So we have a very accelerated laboratory in which to develop drugs and protocols to maybe address that. And that's what Kelly was talking about.
And nutrition too, because they're learning that nutrition and exercise in combination have a really important effect on how well you're able to keep fit aboard the space station.
I'm sure you've heard that one before too.
Next question.
I'm John Gilbert. I'm a senior. I wanted to know, how did your Navy career prepare you to be an astronaut?
Good question. My Navy career, I was a meteorologist, oceanographer, and I was also a surface ship uh, uh, watch officer in the Navy. And the scientific part of my background, the meteorology, oceanography, helped with my ability to understand all of the technical parts of what is needed to operate in space, orbital mechanics, and the like. So I have a very rigorous engineering scientific background. The Navy portion of it is the crew of a ship, much like the crew of a spaceship. Is based in operations, and it's very similar when you're operating on board a ship or a submarine to when you're operating in a spacecraft as a crew. You learn to operate as a team. You learn your systems on the ship, and indeed many of them actually they're all the same, save that, for example, there's environmental systems on the ship as there are on a spacecraft. So some of the hardware is different, and how it functions is different, but the principle and why it's there is basically the same. So it's a very close one-to-one relationship between operating in a naval environment as a space environment.
And interestingly enough, one of the crew members on the space station right now also is a Navy veteran. Chris Cassidy was a Navy SEAL. Next question.
I'm Sean. I'm in ninth grade, and my question is, what made you want to be an astronaut?
Well, I've always had a desire to learn new things and to understand the universe, what's out there. But very specifically, when I was very young, at age 5 years old, the first satellite went into orbit, Sputnik, and then shortly thereafter, a few years later, the first human beings, Yuri Gagarin and Alan Shepard, went into orbit around Earth, and I knew then that's exactly what I wanted to do, and I feel very fortunate and privileged to have had the opportunity to do so. And I'm very lucky to be here sitting talking to you about it.
Go ahead. Yeah. What do you think is your most significant accomplishment in all your space missions as an astronaut?
My most significant accomplishment, the most memorable one, was the one on my second mission, was when I did a spacewalk. And honestly, I guess the most significant accomplishment is in my on my last missions. We had a number of technology development experiments on board that spacecraft, both on the shuttle and others that we put overboard and we tested in orbit alongside the space shuttle. And in that sense, is those technology development experiments were pushing the boundaries of what our capabilities are to explore space. So I guess that in my mind would be something that if we can move to an area where we can explore it more efficiently and go farther out into space is something that I hope continues.
And I think some of those were directly applicable to the space station development, weren't they?
Actually, yes. We had attitude control satellite. It's called the satellite test unit. It was a device that we tried to use the forces in Earth orbit to control the attitude of the spacecraft, and in a sense they do that a little bit with the space station. We've got gyros that move through angular momentum that can torque the space station around. We also have thrusters, but we don't use those that often, and we try to keep the space station in an equilibrium point where we don't have to use the gyros even, but all three together hold the spacecraft where it needs to be.
Great. Another question?
Um, how does your body shift to gravity, to no gravity, and how do you feel?
Well, the body does a number of reactions when you get into space and you're in orbit, and the gravity vector is removed primarily, and we had already discussed some of that with the bone density loss, the muscle toning loss. But the most immediate reaction that one feels is a fluid shift. And again, I'm sitting here, or if I'm standing up, gravity is working to hold my bodily fluids, the bloods, in my legs and arms if I have my arms at my side. When you remove the gravity, that there tends to be a fluid shift out of the legs into the chest cavity and the head. And if you look very carefully at some of the pictures of the astronauts in space, they do look a little puffy, a little more full than they do on the ground. And that is because of that fluid shift. Now, a consequence of that fluid shift is what we call space adaptation syndrome. Uh, it's not the same as, but it's not very much different as. It's hard to describe as when you if you go aboard a ship and you have a tendency to be seasick, it is a similar reaction, but not exactly. And you tend not to feel very comfortable. You got this maybe a headache. You might have some nausea. It depends on the individual. And what's the good news is that goes away after a few days. The body adapts. You tend to not notice it anymore. An analogy I would draw is if you ever had a tooth filled, with cavity, and you had a filling done or you had work done on your teeth. The first day or two that you've had that filling, you tend to notice it, but then after a few days or 3 days, you don't notice it anymore. You get used to that feeling, and it's sort of the same with space adaptation syndrome.
Okay, another question.
My name is Brian Brooks. I'm in ninth grade. I'm a freshman, and I wanted to know, what does open space smell like?
Did I get that right? What does space smell like? That's a darn good question. Actually, the direct answer is nobody knows, because space would not have smell if you're outside, because it's basically a vacuum, and there's no way to sense odors because we need atmosphere and air to pass over our nostrils to have a sense of smell. Having said that, there is a sense of odor in space, and that tends to be like new car smell. If you get into a new car, most people like the smell. You take it in, and that is from the outgassing of the materials of which the car is made. And depending upon the spacecraft, in the case of the space shuttle, I was not aware of that. You kind of get used to it because you operate in a similar environment in simulators. You actually train in the space shuttle at times before launch, so you're in the real vehicle, and you're also inside your suits at times. And what I noticed one time after being removed from the space shuttle after several years, I got back inside of one, and what struck me was the odor, the smell of the space shuttle itself, is that combined collective of outgassing from the materials in the space shuttle, at least in the case of the space shuttle, and it it hit me that that's the smell of space. So it's not really the space outside that smells. It's the things that we bring with us that actually give us a sense of orientation from a sense of smell perspective.
Now, you're a veteran spacewalker. I understand there is a special smell that comes with coming back in the airlock after a spacewalk for some folks.
Yes, when you come back in and pop your helmet off again, that odor of the spacecraft that hits you, it's like a sense of home. I mean, if you walk into various retail stores or somebody's home, there's a slightly different characteristic odor, and that's, if it's your home, and and if it's something wrong or different, then you'll notice it.
Okay. Well, I understand that's all the time we have for today. We want to thank you folks for being with us today. And thank you, Mario,
My
for
pleasure.
joining us and answering the students' questions. We hope you have a great rest of your day and a great weekend.
Take care, guys. Thank you.